if we hope to have a decent world for our children and our grandchildren. We simply must balance our demand for energy with our rapidly shrinking resources. By acting now, we can control our future instead of letting the future control us.
This is a gas station. I'm sure you've all heard of or been to one. Oil powers a lot of things from cars to heating to stoves, but we also know oil isn't the best for us. And that mixed with the fact that there was 140.43 billion gallons of gas used and 246.3 trillion vehicles miles traveled in 2015, that brings up a serious issue. Our car's engine releases carbon dioxide, nitrogen, sulfur oxides, hydrocarbons, particulate matter, and much more. But what's the worst fossil fuel you should be worrying about? The one that causes the most damage? Coal is made from dead organic material that settled on the ocean floor and got pressurized into the making of rock. The coal is made into energy by coal-fired power plants. First, a pulverizer grinds the coal into a fine powder. Then the coal powder mixes with hot air and the mixture moves to the furnace. The burning coal heats in a water boiler, creating steam. The steam released from the boiler powers an engine called a turbine, transforming heat energy from burning coal into mechanical energy that spins the turbine engine. The spinning turbine is used to power a generator, a machine that turns mechanical energy into electrical energy. But all the while the coal is being burned, it's also releasing vast amounts of smoke. Coal-fired power plants fuel 37% of global electricity. This means for countries such as South Africa, 90% of its electricity comes from coal-fired power plants. 74% of steel is made from coal. And the U.S. burns about 1 billion tons of coal per year, so you can imagine that's a lot of bad stuff going into the air. But carbon dioxide and greenhouse gases are not the only downsides of coal. And of course, there's some pros of coal too. So let's look at the pros and cons. Let's start with the cons. Coal is formed from plant life buried in the earth millions of years ago. This means it's non-renewable, and we will run out of coal soon enough. It is predicted we have about 200 years of it left. Other than atmospheric and element pollution, it affects other environmental things too. Coal mining requires an estimated 70 to 200 million gallons of water every day. For example, in Appalachia, more than 1,200-mile streams have been buried or damaged by mountaintop removal mining. 400,000 acres of temperate forests have also been destroyed during the same time period. Strip mining is the removal of soil and rock above the layer seam, followed by the removal of the exposed material. This eliminates existing vegetation, destroys the genetic soil profile, displaces or destroys wildlife and habitat, alters current land uses, and to some extent permanently changes the general topography of the area mined. On the health side of it, we've all heard of black lung disease, but effects from coal mining go much further than that. 13,000 people die from coal pollution each year. Additionally, the Clean Air Task Force estimates that every year coal pollution is responsible for 12,000 emergency room visits, 20,000 heart attacks, and over 200,000 asthma attacks. Coal-fired power plants are responsible for releasing dangerous chemicals into the surrounding area. A study at Blacksmith Industries showed that lead pollution from mining accounted for the most pervasive risk to human health in 2012. These power plants are also the single largest source of unregulated mercury pollution in the United States, emitting over 33 tons of toxic mercury each year. This is equivalent to 5 elephants or 2 fists as heavy as the space shuttle. One study even suggested that coal ash and dust may be more radioactive than nuclear waste. Coal plants emit radiation in the form of radioactive fly ash, which is inhaled and ingested by neighbors and incorporated into crops. So, scientists estimated radiation exposure around coal plants and compared it with exposure levels around coal water reactors and nuclear power plants. The result? The scientists estimated fly ash radiation in individuals' bones at about 18 millirems a year. Doses for the 2 nuclear plants, by comparison, ranged from 3 to 6 millirems for the same period. When all food was grown in the area, radiation doses were 50 to 200% higher around the coal plants than they were in nuclear power plants. But of course, with all things bad, there's a good side too. So now let's look at some pros. First, compared to nuclear or gas, coal has a relatively low capital investment. This makes it easier for companies to invest in it. Number 2, it can be converted to a liquid or a gas. This makes formability easier to use, and power companies can transform the coal into whatever state they need for that specific project or source. It also provides affordable energy for low-income families. The low capital investment makes it easy for these types of families to use power at an affordable cost. Its uses are also very diverse. It could be used for heating, cooling, cooking, lighting, communication, farming industry, and healthcare. There are also alternative options to coal. We can use high-efficiency, low-emissions power generation using technology that's available today. These facilities are being built rapidly and emit 25 to 33 less CO2 and significantly reduce or eliminate emissions. So, if the environmental downfalls outweigh the pros, why is so much coal still being used? And why are some countries fully dependent on it? Because of its high load factor, coal produces 19 quadrillion British thermal units of power each year. Oil at 36, natural gas at 26, and nuclear at about 8. Renewable sources, on the other hand, do not produce nearly as much power. Solar power amounts to well less than 1 quadrillion BTUs, hydropower at 2.6, and biomass at 2.7. Wind is just 1.5. This means the amount of power produced by coal is 8 times the amount of all the nation's wind and solar generation combined. And that right there is the problem with coal. We depend on it so much for usage and power, but the environmental downfalls are detrimental. It's very hard to change an economy's energy source. Without coal, whole countries would be without power. This is the case in China. Although the situations of burning coal are on decrease, it's still a big part of China's energy structure. Coal is cheap and stable. Wind and hydro energy are not steady. Solar energy is a good way, but then the problem would be low efficiency and high costs. But in some countries, such as Kenya, they've depended their economies on 68% from renewable sources and 32% from oil. Luckily, costs for producing renewable energy have gone down tremendously. The cost of generating power from onshore wind has fallen about 23% since 2010, and the cost of solar electricity has fallen by 73%. Irina says all renewable energy technology should be competitive on price with fossil fuels by 2020. Onshore wind schemes are now costing an average of 6 cents per kilowatt hour and even some at 4 cents per kilowatt hour, while the cost of solar is down to 10 cents per kilowatt hour. The cost of electricity generation based on fossil fuels usually falls in a range of 5 cents to 17 cents per kilowatt hour. Investments in renewable energy or energy efficiency have been shown to create far more jobs. Coal produces a lot of energy, but also has a lot of risks too. There are pros and cons, and although you can argue whichever side, it is evident that we need to switch over to more renewable resources so that we can all prosper and leave the world a better place for our posterity. But until then, fossil fuels aren't going anywhere, and that is the problem with coal.